Hey, welcome back to the channel. I'm Code Hero, and if you're watching this, you're probably in one of two places. Either you're already a staff engineer wondering if you're actually doing it right, or you're a senior engineer asking yourself, what does it really take to get to that next level? Either way, this video is for you. I've been in software for over 18 years. I've shipped iOS apps used by millions of people. I've led teams, survived reorgs, written RFPs, and yes, made plenty of expensive mistakes along the way. Here's what I can tell you after all those years. Being a staff engineer in 2026 is completely different from what it was even 5 years ago. AI has changed the game. The mobile ecosystem has exploded, and companies expect more strategic leverage from their senior technical people than ever before. So today, I'm going to break down the 7 pillars of what it actually takes to be a great staff engineer right now. And for each one, I'm going to show you the exact contrast, what the senior level looks like versus what the staff level looks like, because that gap is bigger than most people realize. One of those pillars is something almost nobody talks about in engineering content, and it might be the most important one. You'll know it when we get there. This is not the job description, this is the real stuff. Let's go. Pillar 1, technical depth and breadth. Let's start with the obvious, but don't skip this section, because most people get it wrong. A staff engineer on an iOS team is not just a really good Swift developer. You are expected to be dangerous across the stack. Yes, deep iOS expertise is still your foundation. Swift UI, UI kit, Swift concurrency with async, await, and actors, memory management, instruments, Xcode Cloud, test flight, provisioning profiles. You should be able to close your eyes and debug a retain cycle or architect a feature in TCA or Viper before your coffee gets cold. But here's what separates staff from senior: breadth without losing depth. You need to understand how Android, Flutter, and React Native work, not to write production code in them, but to have intelligent conversations with cross-platform teams. When someone walks in proposing to replace your native iOS app with React Native, you need to evaluate that technically and strategically. What are the real trade-offs? What does the performance delta look like? What does that decision mean for team velocity? And in 2026, there's a new layer on top of all of this: AI fluency inside your apps. By 2025, nearly half of all production code had AI involvement, up from essentially 0 in 2020. Think about that for a second. Today, it's in almost every codebase. That's a structural shift in how software gets built. And as a staff engineer, you need to understand what that means for quality, security, and your team's standards. Here's the contrast I want you to sit with. A React Native migration proposal lands in a senior's inbox. They research performance benchmarks and give a solid technical opinion at the next sprint review. A staff engineer gets the same proposal on Monday. By Wednesday, they've circulated a written decision framework covering native performance delta, team ramp-up cost, App Store implications, and the long-term maintenance curve. The meeting becomes a decision, not a discussion. A senior gives you a technical answer. A staff engineer gives you a decision framework the whole organization can use. Staff engineers don't just write code, they define what's possible. Pillar 2, architecture and system thinking. This is where staff engineers truly earn their place. You are the person in the room who sees the whole board. Not just the feature being built this sprint, but the system that needs to exist 18 months from now. Let me be direct about something. If you're still arguing about MVVM versus Viper in every architecture review, you're missing the point. The question is never which pattern. The question is, what are the trade-offs given our team size, our velocity, and our roadmap? Great staff engineers in 2026 have strong, well-reasoned opinions on modularization, faster compile times, parallel development, clean boundaries, dependency injection, done right, not over-engineered, clean architecture interacting with TCA in a Swift UI world, and CI/CD as an architecture decision, GitHub Actions, fast lane, phased rollouts. A broken CI pipeline that delays a critical hotfix is a production incident. Treat it like one. Here's the senior versus staff contrast on architecture. A senior engineer proposes breaking the monolith into feature modules. They write a solid design doc for the checkout module, execute the migration cleanly, and ship it. A staff engineer's design doc covers build time benchmarks, a team ownership model, a phased rollout plan, and rollback strategies. And they align with the Android team so the pattern is consistent across platforms. The senior engineer ships a great module. The staff engineer ships a standard the entire organization builds on top of for years. And here's something worth adding in 2026. AI agents are now part of your architecture. If your app has any AI feature, you are making decisions about context windows, retrieval strategies, and latency budgets. That is iOS architecture today. Your architecture is only as good as your ability to explain it to a skeptical VP at 9 a.m. Pillar 3, leadership. This is the section most technical people either skip or get completely wrong. Leadership at the staff level is not about being the loudest person in the room. It's not about having the most commits. Here's something worth understanding about the last few years. The engineers who survived the big waves of tech layoffs in 2022 and 2023, the ones who came out stronger, they weren't always the best coders. They had developed leadership skills. Real staff engineer leadership comes in 3 forms. First, coaching and mentorship. Mentorship is long-term career navigation. Coaching is tactical. Someone is stuck, you work through it in 30 minutes, and you don't solve it for them. Both matter. Here's the contrast. A junior on the team is struggling with async Swift. The senior pairs with them, helps fix the bug, explains the pattern clearly, and moves on. A staff engineer notices the same junior struggling, but also notices 3 other engineers making similar async mistakes. Instead of fixing each individually, they write an internal guide, run a team session, and add it to onboarding. 1 intervention, team-wide impact. A senior solves the problem in front of them. A staff engineer solves the class of problem. Second, influence without authority. You influence through the quality of your thinking and clarity of your writing. Master the design doc or RFC. Third, disagree and commit. You will disagree with decisions. Make your case, document the trade-offs, and if the decision goes another way, commit fully. The engineers who couldn't do this became difficult to work with. Don't be that person. Pillar 4, speaking the language of business. Let me say something that will make some of you uncomfortable. You need to understand the business. If you can't speak the language of the business, you will be left out of the conversations that matter. Here's the contrast. A senior proposes a network refactor, justifies it with, the current code is fragile and slow, gets pushback, surprised when leadership deprioritizes it. A staff engineer pitches it. Our network layer causes multiple incidents per quarter. Each costs engineering time and damages App Store ratings. This investment pays back quickly and improves retention. Gets funded. Same problem, completely different conversation. Let's break down the vocabulary. OKRs. Your technical initiative must connect to a business outcome. KPIs. Crash-free rate. Day 30 retention. Know your product's KPIs cold. CapEx versus OpEx. A custom CI pipeline is CapEx. SaaS is OpEx. Evaluate these trade-offs. MVPs and POCs. A POC answers, can we do this? An MVP answers, should we build this? Kill POCs before they become zombie projects. And now, the Sales Playbook. Here's the reality in 2026. A staff engineer is not just building software. They are selling ideas internally. Every design doc is a sales pitch. Every architecture proposal is a sales pitch. Move 1. Know your buyer. A CTO cares about scalability. A CPO cares about ship velocity. A CFO cares about ROI. Your pitch to each should be different, even if the initiative is identical. Move 2. Lead with the business problem. Nobody approves budgets for refactors, but they approve budgets to reduce production incidents and accelerate delivery. Start with the pain, then offer the cure. Here's what that looks like. A senior sends a Slack message to discuss messy callback code. A staff engineer sends a one-pager business case highlighting open bugs, estimated ROI, and a phased timeline, asking for a 30-minute alignment meeting. Move 3. Handle objections before they're raised. Answer timeline and risk concerns in your proposal. Move 4, close with a clear ask. End with, I need a decision by Friday. Drive them to resolution. Learn to sell or watch your ideas die. Pillar 5. Estimating complex problems like a pro. Here's a question I get asked constantly. How do you estimate something you've never built before? The honest answer, you don't estimate work. You estimate uncertainty. Here's the contrast. A PM asks how long to add offline mode. A senior thinks for a moment, 3 weeks. 6 weeks later, the feature still isn't done. A staff engineer says, I need 2 days to spike the 4 unknowns. Once I validate those, I'll give you 3 scenarios: optimistic, most likely, and worst case, with a clear scope tier for each one. A senior gives you a number, a staff gives you a model, and in 2026, that model needs new variables built in, AI acceleration for boilerplate, and AI review overhead for security scanning. Budget for it, honestly. Break complexity into knowns and unknowns, map your cross-team dependencies, and always come to the table with 3 scenarios. Never give a single-point estimate. Give a range and own every assumption behind it. Pillar 6. AI fluency. Not optional anymore. Let me say this clearly. AI is not coming for your job, but a staff engineer who uses AI well is going to be significantly more effective than one who doesn't. In 2020, AI coding tools didn't exist for most engineers. Today, the overwhelming majority use them weekly. That shift happened in 5 years. Mobile internet adoption took a decade to reach the same penetration. But a lot of AI-generated code is wrong. Developers accept only about a third of AI suggestions on average. As a staff engineer, you need to understand why that code is wrong and build processes that catch it before it ships. Here's the contrast. A senior uses Copilot to write unit tests and generate boilerplate. Saves a few hours per week. Uses it as a personal productivity tool. That's it. A staff engineer does that, but also defines the team's AI usage policy, evaluates LLM APIs, architects the RAG pipeline, writes data governance policies, and builds the quality evaluation framework for the whole team. You must be fluent in RAG, Retrieval Augmented Generation. It's standard iOS architecture now. You must evaluate APIs from Anthropic and OpenAI on latency and cost, and you must own AI governance and privacy risks. Pillar 7. Emotional intelligence and the human side of leadership. I saved this one for near the end because it takes the most courage to talk about honestly. Being a staff engineer is emotionally hard. If you don't develop emotional intelligence, you will hit a wall. Let's start here. Most staff engineers have experienced impostor syndrome, including me. That voice doesn't mean you're a fraud. It means you're paying attention. The contrast. A senior feels impostor syndrome, goes quiet in meetings, and mistakes uncertainty for incompetence. A staff engineer feels it, but names it out loud. They turn uncertainty into a process, not a verdict. Managing people is an entirely different job. Your impact is the environment you create. Psychological safety is the single biggest predictor of high-performing teams. You need to read the room, not just the retro. Feedback contrast. A senior criticizes a PR as too big. The person feels criticized and behavior doesn't change. A staff engineer notices the pattern, offers to pair, and explains how it affects velocity. The person feels supported and behavior changes, leading through dark moments. When a critical release fails or a roadmap gets cut, your team looks to you as the emotional anchor. You have to hold steady while processing your own reaction. Be honest without being destabilizing. Crisis contrast. A feature gets cut. A senior vents in Slack and team morale collapses. A staff engineer processes their own reaction first, then guides the team on what to salvage and how to move forward. The senior reacts. The staff responds. You cannot pour from an empty cup. At the staff level, everyone needs you. If you don't learn to say no gracefully and protect your focus, you will burn out. Technical excellence gets you to staff. Emotional intelligence keeps you there. Looking ahead, what 2030 will ask of staff engineers? By 2030, The technical floor will be significantly higher. AI tools will be as embedded as version control. Teams will routinely work alongside coding agents. 2030 contrast. A senior is an expert developer using AI daily. A staff engineer is the architect of AI-augmented systems. They own the quality bar for human AI code and speak to leadership about mobile AI risks. Okay, let's bring it all home. Being a great staff engineer is about operating at multiple altitudes simultaneously. Deep enough to debug, high enough for business reviews, and human enough to hold your team together. Pillar 1, technical depth, a decision framework. Pillar 2, architecture, shipping the standard. Pillar 3, real leadership, solving the entire class of problem. Pillar 4, business acumen, building the business case. Pillar 5, estimation, giving a model with AI variables. Pillar 6, AI fluency, owning the platform. Pillar 7, emotional intelligence, responding as an anchor. None of this happens overnight. I've been building these skills for 18 years and I'm still learning, including the emotional ones. But the engineers who are intentional about all 7 pillars are the ones who change the trajectory. If this resonated, like and subscribe, and drop a comment below. Which of these 7 pillars is you're quietly working on right now? I want to hear it. I'm Code Hero, and I'll see you in the next one.